Welcome everyone. Good morning, good afternoon, good evening, wherever you are. Today we are going to talk more about the data exchange. It's a next generation collaboration and data exchange tool. We'll be mainly talking about what leads to creating silos, especially the data silos, and how data exchange creates a synergy to optimize the collaboration and data sharing across the heterogeneous workflows as well as products. So today I am joined with Gaurav. He's a product manager from Autodesk team. Then we have Rohit and Abhishek. They are leading the team at CCTech who works on creating multiple data exchanges. This is the outline of the talk today. We'll briefly talk about data exchanges. What are the typical challenges the customer has shared with us over the last few years in terms of what challenges they are facing to share the data, what challenges they are facing in terms of duplication of the data. We'll also look at some staggering stacks because of this data loss issue. Then we will talk about briefly about what different data exchanges that CCTech has created along with Autodesk team. And then we will dive deep into a case study. This is close to reality case study about metro rail stations. The metro is being constructed in Pune, so we thought of creating a good test case study around it. We'll also share, we have recently done a GA launch of two connectors which Systec has developed, Rhino and Tekla. We'll talk about it. And then we'll also give you a brief about if you really want to experience the smoothness and increasing your work efficiency through data exchange. We'll talk about where you can have a look at those data exchanges where you can find more information about it. So over to you, Gaurav, about more, if you can share more details about data exchange.
Yeah, thanks, Vijay. So basically, I'll just quickly give a brief on what data exchange is. So data exchange is basically granular subset of your design data. Say, for example, your Revit model, your AutoCAD model, your Rhino model, and it's basically a neutral subset of your data that resides on ACC, which can be easily shared with other applications and other stakeholders in your project using the power of platform, the granular permission that ICC provides, and makes it easy to collaborate between different teams. If we go on to the next slide, uh, this is just a visual representation of how your workflows might look like when you're operating with data exchange. So say for example, if you are a Revit designer or a Revit detailer who wants to share the details of their building with downstream Rhino detailer who wants to do intricate details on your facade or floors or ceilings, etc. So you can create that subset of your Revit model and easily share it into Rhino or to any other custom application that you build on top of data exchange, because data exchange has different sets of a set of offerings which allows you to leverage the APIs behind data exchange to load to load this data, as well as create a custom application of your own, which is shown in the lower right corner of this graphic. A third party custom application, we say for example a web view that you want to share and where you want to share the design details. This can be also expanded to other applications like Inventor, Tekla, Rhino, Civil 3D, etc. So we go on to next slide. Here are some of the challenges that data exchange is trying to solve, and I think Vijay briefly touched upon it, and we'll see it more as we go through this presentation. But what we've been hearing as a pain point from customers is most of the times when it comes to interoperability, the data is very lossy. The moment you extract a file, say for example a DWG, or extract a file out of your design model, it tends to lose some context from the authoring application, and which might be important downstream. Say for example some properties, some design details that you need from your authoring application. So that and then we see a lot of folks trying to rework and create those details again onto the downstream application or downstream workflows. That's one of the challenges. Here are some quotes from the customers that we've seen, expressing the need for data exchange. If we go on to the next challenge, the next challenge is more towards the rework and duplication. As I briefly talked about the Rhino and Revit workflow, most of the times we have our conceptual drawings or conceptual designs in one application, and we need more detailed design in another application, and the teams tend to rework the whole design on the for detailed designs or detailed drawings. So that is where we can solve the interoperability problem. And today, when we try to get these files from one application to another, there is a lot of miscommunication, a lot of data loss, and a lot of time spent in reworking the drawings or reworking the things that you've already built. As you can see, one of the customers rightly quoted, we spend more time fixing the broken files than actually designing those. I could relate to that. That's my past life. I've been into BIM management and BIM modeling, so we know how tedious DWG cleanups can be, and those are some of the pain points that we're trying to solve here. Uh, so with this, I'll hand it over to CC team, Vijay and team, to talk more about what challenges they are kind of trying to solve and what opportunities they see with these solutions.
Thank you, Gaurav. So, Praveen, if we can have, what we will have is we'll have a couple of, few polls to just understand from where you are coming and what challenges that you are facing, and that will definitely help us to shape our talk in this webinar as well as in general the future roadmap. So, it will be great if you can, share some details about how exactly, you are operating in your own environment. You must be seeing the poll on your screen.
Yes, I'm getting the responses.
Great.
Ten more seconds and we'll end the code.
Great. And Praveen, if you can share the results of the poll, I see that.
Yes, yes, it's visible.
Great. So I think as expected, the biggest challenge is of course the file format compatibility. We are working in one, let's say CAD tool, and then we want to transfer that data to other maybe a CAD or design tool. So the file format compatibility is definitely one of the biggest challenge appearing from the poll as well as our experience working with the customer. The second biggest challenge is the data loss. Of course, about 25% people are saying that it's a data loss, and that typically is because of your own, CAD or native file or native data is getting converted into something neutral file formats, and of course, the translation causes the data loss. And if the file size is big, if the model is big, which is a typical environment that we operate in, that is one challenge that many of our customers are facing in terms of transferring data. So these are some of the kind of stats uh, which are we have captured across. This is applicable, some of them are applicable to a construction industry, some of they are in general applicable for solving the issue of transferring the data, and what is experienced is data loss, lack of seamless exchange of course leads to massive waste, and which eventually leads to a slower project execution. About $15.8 billion per year is lost because of inadequate interoperability. About 177 staggering 12 billion dollars per year is wasted because of fixing the mistakes, because of searching the data in different file systems which are used, resolving data issues. I think this is a massive waste of resources across the industry. We have typically noticed that about people or companies or different design teams shares 10x large models compared to what they should share, considering different roles in the whole design or business process. We have also noticed that if we make some sort of a data automation even 5x faster than what it is today, it leads to overall 10% saving in the cost. And similarly, smarter translation or the healing methods that if we use, it reduces the file size by about 10 to 13%. These are some of the very interesting figures wherein we see that is this whole technology is leading to a saving of a cost, and that directly it is leading to the efficiency of the project execution. So at CCTech, we have been working on data exchange for last, I think, 4 years, starting with dabbling with this technology when it started at Autodesk, and then slowly we associated ourselves understanding the technology as well as developing some of the data exchange connectors in association with Autodesk team. And we have also independently developed our own data exchange connectors in our production level products, which is buildings AI. And we have also launched a commercial data exchange which takes data from different CAD systems to your PowerPoint presentation. And with Autodesk, we have developed connectors for AutoCAD, Civil 3D, Tekla, Navisworks, Rhino, and Dynamo. These are some of the connectors that we have developed at CCTech. So now let's go into a case study. This is a close to realistic case study, I would say. This is not a real customer case, but it's very, very close to realistic case study in terms of the complexity as well as the size of the project and heterogeneous nature of the typical teams that you experience. So this is about designing a metro station. Typically in Pune, we have taken kind of a pictorial view of how a metro station, one of the metro station in Pune looks like. And then we try to create that metro station through this data exchange workflow. And in this case, which is a typical scenario which we have considered, is there are multiple teams, engineering teams works out of Pune or Delhi. The consultants or review who are approvals or reviewers, they work out of Hyderabad. And in this case, the sponsor or client is Government of Maharashtra, Mumbai. And the project team uses multiple products, Revit for conceptual design, beam modeling, Tekla for structural, AutoCAD for MEP kind of modeling, Inventor for typically a fabrication kind of modeling. Navix was typically to check how all the design streams are coming together. Are there any clashes happening? Is there any conflict happening between the positions of different streams or data which is coming in? The major objective is, of course, on a client side to meet the scheduled project timelines which has been defined, and for the company to whom the contract is awarded, their objective is how they can do a smooth execution of the projects, how they can meet the timelines which has been proposed by the client, how their different teams can do effective collaboration, how accurate data is being transferred, how efficiently it is transferred. These are some of the typical objective in which we have seen in such kind of a large project. So this is a broader picture of what this project is. Now, in terms of project ecosystem, typically the software ecosystem architect uses Revit, structural engineer is using Tekla, draftsman is using AutoCAD, and then there are support functions, support team, they might be using Excel, PowerPoint, Power BI kind of reports to see the progress. Same as that of project owner from APC company, they want to see the progress of the project, and then some curated scheduling and reports also needs to be viewed by the client, in this case, which is government. This is a typical project ecosystem that we have assumed and considered. These are some of the personas and their roles. In this project, we have considered this, but whoever is attending the webinar, they might understand that this is a typical landscape of any project that we execute. That multiple streams are involved, multiple people are involved with different roles, as well as different ecosystem of the products. In this case, architect is on Revit. He's using Revit, and his role is to create conceptual and architectural design of the station, metro station. Structural engineer is using Tekla. His responsibility is to design structural design of beams, columns, frameworks, etc. Draftsman AutoCAD, he's on AutoCAD, and he is responsible for developing structural, architectural, or MEP kind of layouts. Fabricator, he is on Inventor, and he is in responsible for creating different fabrication drawings, like laser cutting workflows and so on and so forth. Then we have a purchase or procurement department, which is involved into estimation of the material consumption, material acquisition, so on and so forth. Then we have a sponsor or a client who wants to know the overall progress of the project. And then we have engineering support team, which provides additional design and coordination support. So this is a typical ecosystem that we have considered in this case study. But if you have a look at this whole template, you will see that it's a generalized environment that we all work in when it comes to a large scale engineering project. So I think we will have one more poll to understand what kind of ecosystem that you use. Again, this will help us to understand the landscape. So what softwares that if you use any of these, you can vote, so that we'll have a picture about what is the ecosystem that you are in.
We have received good amount of response for that. I'm stopping that poll. Can continue.
Great. So thank you for sharing the data. Out of confidentiality, we are not sharing the output of it because it talks directly about the products that you are using. But we see majority of you are using the product that we are imagining that which involves into this kind of workflow. And I'm glad to see the response and see that we already have a good solution for the products that you are working on. Now moving ahead about the test case, we have defined some personas which we already discussed, but let me lay out an additional detailed picture about it. And we have named the Revit guy, Mr. Architect, and he is based in Pune. And he had just finished a conceptual design layout in Revit, and he wants to send it to a further downstream detailed design team, which is want to do a structural design. And considering the conceptual level of a design, the file is about 600 MB. He is using IFC as a method to share this data from Revit to a downstream Tekla application. And he is using available methods, either email or a drive or Google Drive or some sort of a shared drive, wherein he is putting his file and the structural guy is pulling that file for his further work. And then when it comes to a structural guy, typically he only wants to have a plan layout and grid level, but he needed to import the whole IFC file because that curation, that federation is not available at the way the data is being shared to him. and then he has designed the beam and columns, but he sees that somehow it is clashing with some of the other beam elements. He again sends back the message to the Revit guy, saying that there are some clashes, but I am putting my structural design elements in the design, and I'm sharing back the file. It goes back to the Revit guy, and then he looks at it. He modifies some level of structural elements, and resolves that overlapping issues. And he says that I have made the changes in my design, and then now it looks fine. Please have a look at it. And it comes back, and he says that it's okay. We can proceed further. But this is just one workflow about a conflict of one stream, which is structural element getting designed, and somehow their positions needs to be tweaked in with respect to other architectural elements. But this is just one workflow. You can imagine there are multiple workflows like this. There are multiple design elements considering each of aspect. Let it be a beam modeling and let it be a structural analysis. And they do a lot of to and fro analysis, to and fro sharing of a data, exchange of dialogues to make sure that they are in sync, at least as far as their own roles and responsibilities are concerned in this whole design cycle. Now let's imagine that this is done from their side. Then it goes to AutoCAD guy who is responsible for creating MEP components design, and he needed to download both architectural structural IFC models so that he can get the complete view of it. On top of which he can build the so-called as MEP model, and of course for him the model is pretty large considering both design streams are currently included in the file which is being shared with him, and he needs to do a lot of pre-work before even he starts his own modeling. He needs to hide few things. He needs to uh, isolate few things so that he can get into his own work, and then after that he works on that part. Again, to and fro happens. A lot of data files are being shared across multiple ways of the way, whatever ways which are available to them. Then comes our inventor guy. The Rhino person has kind of designed overall look of, let's say, facade, or the grills that we put, and then he needs to create a fabrication drawings, the cutting, laser cutting workflows. And again, because of the size of the file which is being shared, which is being accumulated so far by different streams, it becomes pretty difficult for him to navigate through this file and create his own cutting workflows or related drawings. And then there are other stakeholders like the client, government of Maharashtra, for example, a guy sitting in Mumbai. He wants to see the latest project updates. He wants to see where we are today, kind of questions that he has, and he's looking for that data. Then we have a project manager. He says that I have received yesterday's file, but looks like some changes has already happened over one day. I want to see what exactly is the current status, and send me the current status file, so and so forth. And then we have a reviewer. He is looking at something is wrong in the design, and he wants to verify it with so-called as a clash detection available in Navisworks. And he says that, oh, there are so many clashes currently I see, considering multiple streams, multiple domain designing is being involved. And imagine the whole rework is going to be done by different streams to resolve those clashes and finally get into the final design, which can we can push it in further pipeline of design process. These are some of the summary of some of the main pain points. For example, an architect, he is okay, very strong word, but forced to use a very heavy IFC kind of a translation instead of sharing only the required data to a downstream application. He need only a partial structural update, but he has to again get back the whole file from the structural Tekla guy and then do some modifications Revit. Similarly, a structural engineer, he has imported again a big file which is not necessary for his work to be done, and again he has experienced some clashes and he wants to revert back. He wants to recycle, again execute the same process to resolve those conflicts. Again, Revit, the Rhino guy, he has performance issues because of loading the entire model into the workspace, and wherein he only requires the outer or peripheral design and not the whole data set. The fabricated again has to deal with the heavy files. He needed only a specific information about the design, which he is not getting through this kind of workflow. So these are some of the typical pain points, apart from the time required to create the translation, time required to share the translation, time required to import the translation, so on and so forth. These are some of the major pain points. So again, we have one more poll. I think this is more around how do you share the data in your current workflows, what kind of file formats that you use, and this will definitely help us to uh, identify some of the bottlenecks you are already experiencing.
There are two questions. You can scroll down to see the second question.
Right. So we'll have two questions around this. One is of course the format with which you are sharing a data, and the way you share the data. I think the format which are uh, I think we'll wait for a poll to end.
Yes, yes. We're getting interesting registration by the Okay, let me share the results.
Okay, as seen, I think 88% people use IFC as a method to translate the data. About 63% use either DWG or DXF to share the data, and about 50% people use Revit. If you see IFC, STEP, IGS, OBJ, these are all neutral file formats, and it has its own limitation in terms of what can be shared, what attributes can be shared, and what data loss will happen when you try to share this data across the multiple streams using these neutral file formats. Praveen, next question.
Yeah, if you scroll down, then we have this.
I see. Okay, and about second question, this is of course as expected. The poll is still running, Praveen?
No, this is done. We got 75% for the cloud platform.
Right. So I think as expected, most of the data sharing platform nowadays is the cloud platform. I think before that we had this, pen drives and CDs and, local drives and things like that. But about 75% uses either OneDrive, Google Drive or Dropbox. And very recently WhatsApp has also came as a data sharing platform wherein it is a chat platform. So these are some of the cloud platforms wherein data is shared. Unfortunately, many of them do not allow or do not have features about versioning of the data. Uh, the uh, the synchronization of data from that place to multiple consumers of that particular data.
Yeah.
Now, what we will see is, I think Abhishek and Rohit will demonstrate quickly a case study that we are talking about, uh, how they have created this metro station design using multiple data exchange. So over to you, Rohit and Abhishek.
Yeah. Yes. Thank you, Vijay, for highlighting the actual pain points the real users are facing during the traditional workflow. Now, we will see how the data exchange with the help of AEC applications can leverage and ease the pain points the customers are facing. So, yeah, can you please? So now we are seeing a 2D drawing we have created in AutoCAD drawing, and now we are only sharing the subset of data from the whole model. So if you see, we have only selected three dataset which will be used by Tekla engineers to develop structural drawing. So now the exchange is created and it is stored in the ACC. Now what we are doing, so we are loading the same exchange created from AutoCAD with the different load options available. Once it is loaded, so yeah, so once the data gets loaded, it will highlight, it will load at a location we have the user has selected. Now you can see the exchange created from AutoCAD is loaded. Now what the structural engineer from Tekla will develop and design and develop structural columns, footings, and then structural beams with the help of Tekla native design options. And from there, he will again share the structural design with the help of different filters. Here we have selected the object view filter, and we have selected the structure as a filter option, and we have created the exchange. You can see the exchange creation is process, and now the exchange creation is successful and it is stored on the ACC. What next part we are doing, so we are loading the exchange created from Tekla into Revit, and here we are developing the architecture part. So Revit is mostly used for structural and architectural part also, but we are for in this demo we will be sharing the architectural design data in the Revit. So here you can see the architectural part is now developed, designed and developed in the Revit application. Here, from here, we will be sharing the architectural drawing by using the selection filter from Revit. We can see the only architectural part from the Revit is selected and now transferred. We have provided a unique name to this exchange, and now we are creating the exchange of this architectural drawing. So now the exchange creation is process, and the exchange now exchange is created. So what next we are doing, so in order to check the model coordination between different application, that is Tekla, then the Revit, so we will be loading this exchange in the Navisworks application. So Navisworks is mostly used for coordination. So we have here we have loaded the Tekla exchange. Now we are loading the architectural part from Revit in the same same exchange, so that we will see its alignment with its original position. You can see the alignments are perfectly aligned. Next part what we are doing, so we have taken the outer portion of the walls from the Revit, and we have created the outer portion of the walls using the data exchange. Here you can see we haven't shared all the models. We have selected only the outer part of the walls, so that the uh, in the Rhino user can create a facade design. So the exchange is created from Revit, and the same exchange we are loading in Rhino. So these are the different layer and properties mapping window. You'll see. So here you can see the only outer portion of the wall is loaded. Here we have designed the facade using the parameter features from Rhino. And now what we are doing, so the facade we have created from Rhino, we are passing it using the layer filter from Rhino, and checking whether it is aligning with our original model in Navisworks or not. So we have provided a unique name in Rhino, and then exchange is created. So we are seeing the progress of exchange creation here. So now as the exchange is now created, we are loading the same exchange in Navisworks, so that we will see it is whether it is aligned with the original metro station drawing or not. So yeah, we can see it is perfectly aligned. Over to you, Abhishek.
Yes, thanks, Rohit. So now we can see the base structure and architectural design is completed by using the multiple equation. Now again back to AutoCAD. We have platform design where the multiple column designs are placed, numbering we can see. And now we are creating the column exchange to create the truss in the Tekla. For that, I have used the the layer option where we have selected only columns and floors and created the exchange out of those objects from the AutoCAD. So in Tekla, we are loading the same exchange, but this time as our original drawing is on the origin, but in actual model we can see that our platform is above from the origin or the ground level, which is around 13991 mm if you consider into the Tekla. And I have just selected that the Z coordinate and loaded the exchange. So the exchange created from AutoCAD will automatically load at the elevation of the 13991 mm, considering the origin of the Tekla. Here we can see that the exchange is loaded into the Tekla. So by referring to these column positions, we are placing the columns and the truss into the Tekla. So you can see we have created the truss design into the Tekla. Now we are creating the exchange of this truss design from the Tekla. So for that, I'm just giving the name to the exchange and creating the exchange. So in this process, I have used the welds and bolts while creating the truss. So it's asking me to whether we want into the exchange or not. So yes, if you want, you can select. If not, so you can deselect and those part will not be included. So for now, welds and bolts are included in our exchanges, and the exchange will be get created. And the progress of the exchange creation you can see onto the our data exchange UI, like what are the percentage of exchanges has been created. So you can see that the truss exchange has been created from the Tekla. So this is the Rhino part where by using this Tekla truss structure, we are going to design the roof and the outer facade panel into the Rhino. As Rhino is the freeform modeling tool where we can design the facade like designs easily. So we can see that Tekla exchange is loaded, and out by referring to that exchange, we have created the facades into the Rhino. So I have organized this facade design onto the specific layers called the outer shell and the platform facade, and just applying some colors to the objects and creating exchange of out of the Rhino. So instead of creating the whole exchange, by using the layer option, we can create the only required data or the whatever the part of the exchange we want to create out of the whole model. So yes, from the layer we can see we have selected only outer shell and the platform facade layer option, provided the name to the exchange, and the exchange creation process is started. So yeah, once the exchanges get created, we will load the both exchange, the Tekla one and the Rhino one into the Navisworks to see the alignment or the model coordination as Rohit has already mentioned. So initially we have load the Tekla exchange, and we can see that yes, the exchanges got loaded and its alignment is perfectly onto the platform base where we actually want. If we have created the exchange from the Tekla at the origin, then we need to like the position, and we have to move the objects to the specific elevation like this. But because of the loading of exchange at a specific location, we can create the exchange directly at the desired locations. And the same Rhino exchange we are loaded, and it's get aligned to the model perfectly. So this is the station design completely. So now we are seeing in Rhino facade, there is a facade panel which is used multiple times. So instead of sharing the whole facade model to the Inventor team, I'm just sharing the one panel out of it by using the selection option and creating the exchange out of it, and loading that exchange into the Inventor part environment basically. So you can see the facade panel is got loaded into the Inventor. So this is a part which we can convert into the sheet metal, and we can perform the like create flat patterns or any other operations like the fabrication operation we want to perform. And just we are exporting the DXF So this DXF we can share with the directly with the laser cutting vendors. They can create the like layout of the tool, and accordingly they can fabricate the panels. So this is the overall video demo of the how data exchange can be used in designing the metro station. Yes. So next poll.
So thank you, Abhishek and Rohit. It was quick enough for us to understand the power of data exchange. I think we have seen data traveling from multiple products to multiple products, not only one-way cycle, but both way we have seen data transferring. And I think this is the power of data exchange, wherein we need not to worry too much about sharing the large files. We need not to worry too much about how exactly this data is being transferred from one place to another place. We need not to worry too much about do I need to share the whole model, and if I share the whole model, what will happen if that the downstream application or any application needs to only work on the subset of the data. I think it's a very good and quick demo about it. So Praveen, if we can have a poll, that will be great. So this is more about your biggest challenges when you talk about keeping data in synchronization. Let's say you are working on, let's say Tekla or Revit or Inventor, and then you need to be in sync with other teams or other domains, so that your data is your work is in sync with them. You are referring always to the latest version of things. So what is the biggest challenge that you are facing to keep yourself in sync with the overall project?
For a few more seconds, I'll get you more responses. Meanwhile, Sandeep, please, you can post your questions on the chat or Q&A option. We'll take those in a few minutes. Okay, I'm sharing the results now. We got good amount of.
Okay, so of course the heterogeneous nature of working different products are they have their own strengths about different domains. So working in different working across multiple design steps, working using different software tool is one of the challenge when it comes to I need to keep myself in sync with what is happening for other design steps or whatever products which are used to execute those design steps. One of the challenge again is there are multiple stakeholders, not only the designers, but also the reviewers, but also the decision makers. And there are other stakeholders who will be looking at the overall project progress and the sanity of the design. So multiple stakeholders also puts challenge in terms of keeping ourselves in sync with what is latest. And by default, the data exchange technology will help us to keep ourselves in sync. You can always pull the latest version of the design. If somebody has updated the design, he pushes the design in the data exchange and the version is automatically created, and then you are also notified that this version is available, the latest version of data is available. Once that notification is there, you can pull that latest version of the design, and then you can keep yourself in sync. So this is by default inbuilt feature and philosophy of data exchange which is available. Now I think towards the end of the webinar we have few data exchange connectors which are recently went into general availability. So if Gaurav, you can talk more about this. It will
Yeah,
help.
yeah, just very quickly, the connectors that we saw in the demo that Abhishek and Rohit shared, the Tekla connector, Inventor connector, and Rhino connector, they've been in public beta for a while, and we've recently graduated them to general availability, so you can use them in your production workflows, and data and Autodesk will be officially supporting those. In addition to that, we already have a few connectors in general availability, like Revit, Power BI. So I would encourage all of you to check those out. There is a link to the blog post. We can share it along the presentation as well. That's pretty much it. Yeah, back to you, Vijay. Vijay,
Vijay,
you
you
are
are
mute.
mute. Yeah. Vijay, you are on mute.
Okay. So Praveen, see if you can, share the link with the audience. So these are the two data exchange connectors Sysitech has worked upon. The data exchange connector for Tekla and Rhino, and now they are available, generally available, GA launch. So you can scan the QR code. It will lead you to the Autodesk App Store, from where you can, download and experience this data exchange connector. I will invite everybody to have a look at it and experience how smoothly you can exchange the data between multiple streams of between multiple products, and optimize your workflows, or enhance your efficiency in terms of the total lead time taken for starting from conceptual design to all the way to a production. And thanks everyone for attending the webinar. I think we have announced this webinar about 6 to 7 days back, so it was a very short notice in terms of scheduling this in your calendar. But thanks to everyone for making out the time and attending this webinar. So we are open for any questions now.
Vijay, we have received few questions in the Q&A box. I hope you are able to see that.
Okay, so we have a question from Jaideep. There are interoperability tools of Autodesk for data exchange. Does your yours perform better compared to it? So who wants to take that? Gaurav, you?
Yeah,
Which
so
tools?
yeah, same question. Like, I'd like to know which tools is Jaideep mentioning about. I mean, are these out of the box export import functionalities from Autodesk or other data exchange tools? Praveen, is it possible to maybe unmute Jaideep and we can hear from him directly? Just
Yes, I've given the, yeah. Jaideep, you can unmute and you can directly ask. I've changed the right, but still, maybe
okay.
some issue with the mic or something.
So Jaideep, if you can unmute and give us more clarity about which other tools that you are referring to, we'll be able to, answer this question better way. Okay, so I think, overall, I think data exchange is the one that we see available at Autodesk in terms of, exchanging the data around data interop kind of solutions. So data exchange is the one. We'll be very happy to answer your question if you share, later on, if you share more details about which tools that you are referring to, so that we'll able to clarify more about what are the advantages of this tool and the available tools that you are referring to. Okay, any other question, Praveen?
Not really. Actually, please, we encourage you to post more questions. Meanwhile, some of the team can say some like frequently asked questions or anything from the past, so that will be helpful.
Okay. Now, I think one of the frequent question which is being asked is how do we kind of handle the data loss issue, because whenever we get into a neutral kind of a file formats, right, we see the translation and data loss issue, but how exactly the data exchange is resolving that typical issue of a loss free kind of translation. So maybe Abhishek, Rohit, or Gaurav, if you can put more lights on this question. This is the question which we have heard whenever we demonstrate to the customers and ask them to use this solution. This is a typical question that comes across.
Yeah. I think on the data loss side, most of the times it is because of the translation. Like if you do an export workflow, that times there are set parameters that it uses, and then in case of exchange, we extract the data directly from your authoring application. So we have more control on what can be sent out of those out of that application, and that way I think we try to minimize that gap between the data loss. So whatever is in your authoring app in terms of hierarchy, in terms of properties, try to preserve it as it is into data exchange. That way you get most of your parameters, properties along with the exchange. And just to touch up upon Jaideep's question earlier as well, I don't know which solutions is he comparing to, but in general, in case of data exchange, one thing that we couldn't talk about in the video or webinar was, ability to keep it updated along with the source application. So, say for example, across the life of your project, you have multiple revisions on your Tekla model or Revit model. Those can be synced in form of the data exchange, so the data exchange version can be updated along with the update in your source model. So the downstream users can easily get the latest information, reducing the overhead of exporting again and then reloading again those files. So that's one of the aspects that kind of sets data exchange slightly apart, and has been very well adopted by the customers.
Okay, so thanks Gaurav for those points. So towards the end, I think I will invite everybody to experience, download the data exchanges, experience how exactly it performs. If you have any questions around it in terms of its usability or how do we, use it in your own workflows, feel free to connect with us. We'll share the details about how you can get in touch with us. We'll also share the details about different, information or material that you can go through to understand this overall technology and different connectors that we have available currently. And again, once again, thanks for joining the webinar. Thanks, Gaurav and Autodesk team again to join the webinar and help us to uh, answer a few of the questions, present some of the details about data exchange. And I'm very excited the way this whole data interop issue is being resolved and tackled at the core. I'm very excited about different innovative workflows and collaboration using this technology. So thank you everyone, and have a good day or good night, and keep innovating.
Yeah. Thanks, Vijay. Thank you for hosting this as well as sharing a great workflow. I think it's really inspiring. Thanks.
Thank you.
Everyone.